Let's do problem 9 on page 322, and I'll read it. Here it is in the book. It says, find the angular speed of the Earth's rotation on its axis. As the Earth turns towards the east, we see the sky turning toward the west at this same rate. So that's part A. Then part B. The rainy Pleiades wester and seek beyond the sea. The head that I shall dream of, that shall not dream of me. Oh, sad. Now, Cambridge, England is at longitude 0 degrees, and Saskatoon, Saskatchewan, is at longitude 170 degrees west. How much time elapses after the Pleiades set in Cambridge until these stars fall below the western horizon in Saskatoon? All right, so here's Earth, here's Cambridge, England, and here's Saskatoon, and the Earth's going to rotate. So we just want to know how much time is it going to take to rotate that much. And the poem will not be on the test. Okay, so you don't just enjoy it. Now here's the thing. I'm gonna get real here in terms of the Earth's rotation. How much time does it take to rotate once? It's not 24 hours, people. 24 hours is how long it takes the Earth to rotate once and have the sun be in the same place in the sky. But as the Earth rotates on its axis, it also moves around the sun. And so the Earth has to rotate beyond one complete rotation and go almost a little less than 1 degree further. So actually, the time it takes to rotate once is 23 hours. Ooh, I just had it on my phone. Hold on. 23 hours, 56 minutes, and 4.1 seconds. Okay, this is how much time it takes for the same star to be in the same place in the sky after one rotation, not the sun. So our 24-hour day is based on the sun, and it makes sense to do that. But what's called the sidereal day, the time it takes the Earth to rotate, see, the Earth actually rotates about 361 degrees in one regular day. But to rotate 360 degrees, we call that a sidereal day. And it's a little bit less. In fact, it's 1/365th less. So just a few minutes. So this is the time it takes to rotate once. So omega is equal to 1 rotation per unit time. Well, 1 rotation is 2 pi radians. Now, we got to get this into seconds. And so this is 23 times 3,600, because there's 3,600 seconds in an hour, plus 56 times 60. Okay, that'll be seconds. And then plus 4.1 seconds. And when I do, I'm off screen, sorry. And so when I do that, I go, 23 times 3,600, and then plus 6 times 60, plus 4 plus 1 equals, and I get 86,164.1 seconds. So I'm going to reciprocate that and then multiply that times 2 times, where's pi on this calculator? There it is. And I get a very slow speed. 7.3 times 10 to the, let's see, 1, 2, 3, 4, 5 radians per second. Is that what the book wanted? I haven't looked it up in the book. So that's the actual angular velocity. Actually, if you round off to two significant figures, you probably get the same answer if you use 24 hours. Not that big a deal. I just wanted you to know that the Earth does not rotate on its axis once every 24 hours. It rotates a little bit more because it's moving around the sun. So this is A. Is that right? Did they put it in radians per second? Okay, you guys aren't helping. This is number 9?
Yeah.
Oh, 7.27 times 10 to the negative 5 radians per second. Yay. All right. So, how much time does it take to rotate that? Well, for part B, delta theta is equal to, let's just do it, omega naught times t plus 1/2 alpha t squared. But what is the angular acceleration of the Earth? I hope it's 0, right? If there was angular acceleration, we'd be in big trouble. All right. So that's the equation we want to use to solve for time. Time is going to be equal to delta theta over omega naught. Now, delta theta is 107 degrees, and omega is 7.3 times 10 to the negative 5 radians per second. Well, we got to get this. There's 360 degrees in 1 radian. So that'll cancel out the degrees and leave radians. What's that? Oh, thank you. Thank you. 2 pi radians. I was just testing you. Actually, this is why I like to do this live instead of by myself, because I make mistakes all the time. All right, 2 pi radians is 360 degrees, so that cancels out the degrees. And now we just need to get the time. Let's see, 107 times 2 times pi divided by 7.3 times 10 to the negative 5 divided by 360 equals, yikes, I get 56,591 seconds. That doesn't seem right to me. Did I make a mistake? 107 times 2 times. Yeah, that's wrong. I knew that was wrong. You know why I knew it was wrong? Because 107 is about a third, a little less than a third. So it should be about a third of a day. Instead, I got something that was more like 2/3 of a day. I don't know where I made the mistake when I punched it in, but it's 24,148 seconds. Now, if you want to do that in hours, that would be 3,600 seconds is in 1 hour. So that would be about 6.7 hours. I don't know what the book did. I think the book did it in minutes, but so there you go. And that's problem 9, beaten to death. Okay, crushed into submission. That is all.